is I have also given that to you in your account as well. I mean, in the OneNote only. Okay, I'm going to show you here. So this is the OneNote. Goes by the name of Webinar Chemistry, and you'll be able to see this is 23rd Feb, which is today. And here you can see the sample paper that I was talking about actually. Okay. See, this is the kind of question I was actually talking about, and I think I have shown you this kind of questions before. So this is an by looking at this question, you have to figure out what is A and B actually. You can understand this is an aldol product, right? So how do you actually recognize an aldol product? As you can see over here, it's an alpha beta unsaturated carbon. This is a carbonyl whose alpha and beta have unsaturated segments, right? Forgot to turn on my camera. Just one second. I guess all of you can see it. So this particular question that you can see here, you can say alpha beta unsaturated carbonyl. So this has to be an aldol condensed product, right? Similarly, if you just go deeper down in this paper, you'll be able to see there are more questions like this. Okay, like 90% of the questions are like this only, and the kind of question that we are going to discuss today, the ABCD type question that I'm talking about, you'll be able to see there are many questions they are putting under this concept. Okay, from here only there are 3 questions of this type. Let me show you. We just go through this paper. Okay, I've uploaded this in the OneNote only. Just go through this paper. Yeah, there you go. I have taken these questions for today's discussions, guys. So don't need to worry about it. Oh no, this is different. The case-based questions. Yeah, there you go. Second question of this type. So there are many questions actually they have taken of this particular type. All right. So make sure you go through this particular paper to have an idea about what kind of questions they're gonna give you in this year's boards. Now, guys, let's get started with the Blackboard questions and the one in RW group. So haven't they sent it in the RW group, Aditya? I'll make sure they do that, okay? Don't worry. I would send it. No worries. Okay, guys. Now, so again, guys, whatever I'll be solving today would be there in this OneNote. I'd be trying to complete all the ABCD type questions from here, but you can get the rest of the questions solved by me again in the format of a PDF, and just make sure you go through that part. Okay. So there's the question that you're trying to send me. Would you send me in my WhatsApp? I guess that would have been better for me. All right. You have my WhatsApp number right here. Just send it over to me in my WhatsApp. In the meantime, guys, let's get started with this. Be active, guys, while we are trying to solve these questions. Our target would be gathering hints from every single statements that they are giving you over here. Okay. Right. Okay, dear. I'll be just checking that question in a minute. Okay. Now, guys, let's start with this particular question. What are they saying here? An organic compound with molecular formula C9H10O forms 2,4-DNP derivative, reduces Tollens reagent, and undergoes Cannizzaro reaction. Okay. First, whenever this kind of question comes, guys, I would suggest you to find out the double bond equivalence. We all know how to find out the double bond equivalence, right? You have to find out the double bond equivalence, which goes like, the formula goes like A plus 1 minus B minus C divided by exactly degree of unsaturation thing, the same thing, right? So first, guys, you have to figure out the degree of unsaturation or double bond equivalence, whatever you are comfortable with. Okay. Okay. Now, like I was saying here, so whatever you're comfortable with, you find that value up. Okay. So over here, as you can see, the number of carbon is A, guys. The number of hydrogen is called B, and the number of oxygen is called D. D is not in this formula, so you don't have to worry about D over here. So don't worry about the number of oxygen. Just the carbon and hydrogen is what you have to worry about here. Okay. Now, Now have a look, guys. Here, the number of carbon is given as 9. So 9 plus 1 minus B minus C by 2. So 10 minus a charge. What is C? C is the number of nitrogen. Okay, C is the number of nitrogen over here. There is no nitrogen, so no need to worry about that. 10 minus 0 by 2. So what is the value coming then, guys? 10 minus 5. So the value is coming as 5. Right? Okay, Tejas, let's figure out. So now, guys, what is this double bond equivalence giving you? It giving you the number of rings or double bonds present in your molecule. Correct? So either you have 5 rings, or you have 5 double bonds, or you have 3 rings, 2 double bonds. So it's like all the combinations that can happen for that. Correct? Okay. Now you go solve this question. This double bond equivalence is always going to give you an idea, a cross verification to your answer, whether your answer is right or wrong. That cross verification is something that you're going to get from this particular thing. Now here, it is giving you 2,4-DNP derivative. So 2,4-DNP derivative means, guys, what is this functional group here? 2,4-DNP derivative. Who gives us? Come on, write it down quickly, guys. We're waiting for you. Which systems undergoes 2,4-DNP derivative? That's why I wanted to see it. Okay, guys, you are supposed to write carbonyl systems, right? Aldehydes and ketones both. Some of you are writing aldehyde and ketone both. Some of you are writing aldehyde, some of you are writing ketone. Guys, both of them can give 2,4-DNP derivative. Make sure you know what is the structure of 2,4-DNP and how to make the derivative. Okay, oxime structures, 2,4-DNP derivative structures, shift base structures. You should be able to draw all these three things. All right, guys, and semi-carbazide. These 4. Okay, all of them are there in the aldehyde ketone carboxylic acid chapter. There is a list you'll be able to see, right? So when aldehyde or ketones, they react with nitrogen derivatives, then what happens? Make sure, guys, you go through that list. Correct? Now 2,4-DNP derivative means it's aldehyde or ketone, any one of them, right? Both of them can give 2,4-DNP. Yes. Now after that, it is reducing tolerance reagent. It is reducing tolerance reagent. That means, guys, it is aldehyde. It is aldehyde. Tell me about the name of an aldehyde, guys, which reduces tolerance reagent but doesn't reduce spelling reagent. Let's see who can give me the answer. Give me a name of an aldehyde which can reduce tolerance test, which can give tolerance test but not spelling test. Okay, I got only 5 answers out of 38 students. Which molecule can give tolerance test but not spelling tests? Yes, very good, guys. The answer is benzaldehyde. I hope you know the reason as well, right? Do you not know the reason as well? Fellings reagent is a mild oxidizing agent. Tolerance reagent is comparatively stronger oxidizing agent. Now benzaldehyde is getting a plus R effect shown by the benzene ring. As a result, the mild oxidizing agents cannot oxidize it to carboxylic acid, but the strong oxidizing agents can. So that's why tolerance reagent is being a little stronger oxidizing agent. It can reduce, but not Fellings test, not Benedict's test either. Benedict's test is also there, guys, same as tolerance reagent. Benedict's test is also there. So benzaldehyde doesn't give, remember this, okay, doesn't give Pelling plus Benedict. Okay, it doesn't give either of them. Only tolerance reaction is something that it is gonna give. Okay, now anyway, now and undergoes Cannizzaro reaction, guys. What do I mean? What do they mean by Cannizzaro reaction here? What is the hint they're trying to give you here? Very good. It is undergoing Cannizzaro reaction. That means it has no alpha hydrogens. It has no alpha hydrogens. Right? So now you have to draw a molecule, an aldehyde specifically, which is having no alpha hydrogens in it. So come on. And this is going to be your molecular formula. So give it a go, guys. Okay, there is one more thing that I forgot to tell you. On vigorous oxidation, it gives benzene 1,2-dicarboxylic acid. What's the name of benzene 1,2-dicarboxylic acid, guys? What's the trivial name of it? Very famous molecule. Benzene 1,2-dicarboxylic acid. What do we call it? Very good, guys. It's called phthalic acid. Correct? Gabriel phthalimide, no, not phthalimide here. In Gabriel phthalimide, phthalic acid plus ammonia. We react them together to get phthalic. Correct? So this is the molecule, phthalic acid. Now we get it by vigorous oxidation. Right, guys? Now see, one of the segment is aldehyde that has been given. That means one of the carbon system was aldehyde. It is already given to you. Correct? So aldehyde on oxidation gives you carboxylic acid. So this is done. What about the other segment? What was it, guys? Now see, in order to figure it out, what was the other segment? Very good, Devabrat. Very good, Tejas. So guys, what did you do then? In order to figure it out, all you have done is you have looked into the molecular formula and you have figured out that here there are 7 carbons so far. And how many hydrogens? 1, 2, 3, 4, 5, 6 hydrogen and O. So what is lacking right now? It is lacking by 2 carbons. How many hydrogens? 4 hydrogens. And that's it, right? 2 carbons and 4 hydrogens, isn't it? Correct. 2 carbon and 4 hydrogens. So what will be the molecule connected here? So guys, you can clearly understand it's going to be CH2, CH3. Now you find out the molecular formula here, you'll be able to find it as C9H10. Okay. So it is an ethyl group here. Now guys, I'm going to give you exactly 1.5 minutes to figure out the next question. I guess all of you did understand how to solve these kind of questions. By the way, let me show you how the double bond equivalence is coming as 5. Let me show you that as well. So see, one ring is there. There's a ring that you can see. That means for that you have a DBU contribution as 1. There are 3 double bonds, correct? So for that, 3 more. There is another double bond here. The total is 5. So how do we know that 1 COOH would be there? No, better they have written now. It gives 1,2-benzene dicarboxylic acid. So they have written that it has 2 carboxylic acids, right? Now, what have you learned? You learned that alkanes, when you oxidize them, they become alcohols. When you oxidize them, they become aldehydes or ketones. When you even oxidize them, they become carboxylic acid, right? So now they told you that there is a benzene ring with 2 carboxylic acids. On vigorous oxidation, we got it. That means in these 2 positions, either you had aldehyde ketones, or you had alcohols, or you had alkanes. That's why on an oxidation you got carboxylic acid. Correct? Like any one of them, if I take and if I vigorously oxidize, then all of them would turn into carboxylic acid only. Now see, the previous 2,4-DNP test, tolerance reagent, they have given you the idea that there is a one aldehyde groups already. Correct? So that means one of the carboxylic acid is coming from aldehyde segment. Are we clear up to this? Because that has been given in the hand. So what is the reason behind the other carboxylic acid? So the other carboxylic acid is coming from this CH2CH. How did I figure it out? I just compared the molecular form. I figured this out. Now, guys, I guess you have learned that when you react this with KMNO4, although there are 2 carbons, you are not going to get 2 carbon carboxylic acid. You are going to get 1 carbon carboxylic acid because the oxidation happens on this carbon, right? So your product would be phthalic acid. So however long your chain is, you'd always get 1 carbon carboxylic acid. Okay, guys? This is there in the carboxylic acid chapter. Go through that part as well, right? Okay, this is just the first question, guys. No need to worry about it. We'll be solving a few more questions. You'll be comfortable by then. Correct? Now, I'm going to give you 1.5 minutes to solve this question. Read it up, guys. This is a similar kind of question. Your time starts now. I'll be taking all of your doubts, guys, but first solve this question. Great, Tejas. You have given the answer within 10 seconds. I'm really impressed. You go for the third one in the meantime. Better make sure in the end you cross verify the molecular formula and the double bond equivalence. Both of the things. You have 30 seconds left. Just check one more time, Tejas. I don't know whether that's right or wrong. I need to check it. Raise your hands, those who have given an answer to this question, guys. It's been 1.5 minutes. I'm gonna give you 30 more seconds for the rest of the students. Appreciate those who have given the answer to this question. Very good, guys. Ketanvi, K Vaishnavi. Just raise your hands, guys, the moment you give an answer. All right, Tejas. Let's see. Just check that whether the molecular formula is matching or not. Let's check that. All right, guys, it's been 2.5 minutes. So let's put an end to this. So right now I can clearly see only half of the students, even less than the half of the students were able to solve this question. So guys, make sure that you go through the PDF that I'm going to share. I'll be solving every single question in there as well. All right. Now, if you got the answer right, guys, then keep your hands raised. Otherwise, lower your hands. Okay. Let's figure this question out now. So an organic compound with the molecular formula C8H8. What did I tell you? First, you find out the double bond equivalence. Okay, or degree of unsaturation. So what would that be, guys? A plus 1. The number of stoichiometry of carbon you call as A. This is B. Okay. A plus 1 minus B is 8 minus C. C is the number of nitrogen, correct? Which is 0 by 2. So that is coming as 9 minus 4. All right, Sarvara. All right, Krishna. Let's see, guys. So again, guys, the value is coming as 5. Again, the value is coming as 5. Now, a short, like something, it's like something that you have already figured out, I guess. Always remember, guys, when the number of carbon and number of hydrogens are very close to each other, you can see C8H8. Or let's say there is C8H9 or H10. If you get something like that, always remember there is a benzene ring in there, or there is an aromatic system in there. When the number of carbon and number of hydrogens are very close to each other. So what is C in DBE? What is C in DBE? So C is A. It's like C A H B N C O T. So number of nitrogen is okay, Victor? Clear? Now. Okay, so guys, the value is coming as 5. That means, and again, whenever you get the double bond equivalent, something more than 4 or 5, that means always remember there is a benzene ring. It's like you get these kind of things from your experience. See, whenever you have a benzene ring, the double bond equivalence is 4 for that, isn't it? One ring, 3 double bonds. So you're going to take 4 out from that only. So it's the kind of a sense that you generate when you solve more and more questions, actually, guys. All right. Am I being like, are you being able to understand what I'm trying to say, guys? Because I'm going a little fast, but are you understanding this? Yes. You are, right?
Yes, sir.
Right, Ishani. Right, guys. Okay. Now, yes, very good, Lina. That's the right answer. Now, anyways, guys, so there is a benzene ring. Now that has been confirmed by the last step as well. This is also giving you benzene 1,2-dicarboxylic acid. Correct? Then we have again phthalic acid present in it. Now what are they saying? Again, see, there is a 2,4-DNP derivative and tolerance reagent is working there. So 2,4-DNP derivative plus tolerance reagent. That means, guys, it's an aldehyde just like we have done before. Now again, what is the other carboxylic acid? What is the source of other carboxylic acid? Now you compare with the number of molecular formula here. So right now, what is the total number of carbon, hydrogen, and nitrogen do I have here? So you can see we have 6 carbon and 1, total 7 carbon. How many hydrogens? 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen. Correct? And okay, there is one more. I forgot to do that. 5, and there is one oxygen here. C7H5. Now what are they giving you, guys? C8H8O. C8H8O. So what are we missing right now? We are just missing a CH3 here. Correct? Now if you got this as the answer, guys, keep your hands raised, otherwise lower your hand. Someone of you were actually complaining about the number of hydrogen in the previous question. See, the hydrogen is 10 only. Just check it once more time. It's not 11, it's 10 only. 3, 4, 5, 6, 7, 8, 9, 10. Okay, great work, guys. You can lower your hands now. How many of you got it correct? Let me see. Just one sec. 30. Not a good number, guys. Out of 42 students, only 13 of you got it correct. Okay, let's try again for the next question now. An organic compound A with molecular formula C5H8O2 is reduced to N-pentane with hydrazine followed by NaOH. What is this reaction, guys? It's a name reaction. Hydrazine followed by NaOH. Come on, write it down. Which name reaction is this? Very good, Teeth. Okay, let me take the names now. Naman, Tejas, Krishna, Yuvan, Aditya, Teeth, and Devabrat. All of you have done an excellent job. And what about Madiha? That's the right answer. Ritvik, that's the right answer. Do I have more? Akshit, that's the right answer. Very good, guys. And Satish, Fawaz, Shubham. Come on, guys, give it a try. Give it a try. I can give you one hint for this question. Close, Dinesh. Close. That's not the right answer. This is a particular reaction which is there in the aldehyde ketones carboxylic acid chapter. And there is a substitute reaction to this. The reagents are zinc amalgam HCl. This is a name reaction. And instead of this pair of reagents, you can use this reagent as well, hydrazine KH. Yes, Naman. So what is this one then? I guess you have given the answer now. This one is Clemenson. That's correct. Now you get the same product as Clemenson. From which reaction? Right answer, Nandita. Right answer. Kavya, the previous one was right, but what about this one? Sitesh, that's right. Ishani, previous one is right. Now try this one. Parsha, that's right. One last time. Very good. Dinesh, Fawaz, Yana, all of you are right. Kavya, all of you are right, guys. This is called Wolff-Kishner. Wolff-Kishner and Clemenson give you the same product. Correct? What's the product? If you have a carbonyl system, it would make it alkane. The only reaction which is capable of doing that, right? On reduction of a carbonyl, what are we going to get? Right, Aditya? What do we normally get, guys? We get an alcohol. But here we get an alkane clearly, right? That's why it is important. Right, Ritvik? Right, Fasha? So now that means, guys, I have a molecule which has carbonyl segments, right? That's why it is undergoing Wolff-Kishner reduction. And the point is, after Wolff-Kishner reduction, it is giving you N-pentane. That means it's a 5-carbon system. Okay, that was anyway given. But the thing that is a little bit very good, Krishna. The surprising factor is, guys, there are two oxygen in your molecular formula. But see, after the hydrazine KOH treatment, there isn't any oxygen at all, isn't it? The original molecular formula had two oxygen, but now there are no oxygen. What does that mean? That means both of the oxygens were carbonyl oxygens. It can be two aldehyde, or it can be two ketones. Can we make two ketones, guys? It can be two ketones as well. Something like that, right? Is that clear to all of us? As both of them, both of the functional groups were aldehydes or ketones. That's why, guys, it become N-pentane all the way. Because Wolff-Kishner has reduced both the carbonyl segments, right, to an alkene. This much we are all clear, right? Great. Now, what are they saying? A forms dioxazine with hydroxylamine. I've just told you, right? Hydroxylamine is something that we need to do. A forms dioxazine with hydroxylamine. Again, it is just emphasizing the fact again, guys, who gives oxime? Ketones or aldehyde means the carbonyl systems. When they are reacted with hydroxylamine, they give oxime. Correct? Both ketones and aldehyde both each other. Correct? So that's why, guys, this is oxime structure, right? So it has just emphasized the fact that you have two aldehydes or two ketones, right? Now, what is the right answer? Whether you have two aldehydes or whether you have two ketones, that can be figured out by the molecular formula. So guys, you try to draw both the molecules here and see which one is giving you the matching with the molecular formula here. Is this one matching the molecular formula, or is this one matching the formula? Check that. Is both of them matching it? Really? Organic compound is 2, 2, 6, 7, 8. Okay, O2, fine. 3, 2, 5, 6, 7, 8. It's both of them. And there can be another possibility, no? One aldehyde, one ketone. That's also there. 1, 2, 3, 4, 5. Let's try to gather some more hints then. Molecular formula: this reduces in pentane to hydrazine, followed by British honey with NaOH and glycol gives. So we don't have any other options, guys. All the three can be the answers to this question. I guess from the website that I've taken the question, that was incomplete. Guys, would you just search this question in the internet once and tell me whether I have taken the entire question or not? Yeah. It is incomplete. It has to be incomplete. Can I do it for me, guys? Anyone? And tell me whether I have taken an incomplete question or not. Anyways, for the time being, guys, you have all the three options to this. So can you repeat what we understand from the hydrox? Yes, Aditya. Question is incomplete, no? All right. Okay, Naman. Fine then. Acha, from hydroxylamine, what they're trying to say is, from hydroxylamine, what you understand is, see, this reaction is there in the aldehyde ketones carboxylic acid. Let's say you have an aldehyde, or let's say you have a ketone. Correct? In both the cases, when you react it with an hydroxylamine, the product that you get is called oxime. In both the cases, whether it is aldehyde or whether it is ketone, in both the cases, guys, the product is called oxime. So, as they said that you are getting dioxazine, that means there are two aldehydes or two, which we already figured out. But still, this particular fact is emphasizing. Okay, that's all I'm trying to say here. All right. Question is incomplete, isn't it, guys? Yeah, it is. Okay, I'll just search for the particular question when you'll be solving the next one. Okay, right now, guys, we are gonna put on hold to this question for the time being. I'll be searching the entire question and then we'll be continuing from here. For the time being, you'd be looking into the next one. It forms tolerance and iodoform. Okay, I'm gonna look into that here. Thank you for sharing the paper with me. Now, guys, in the meantime, you solve this question while I'll be taking that question back. Tell me what is A and B. That's all they have asked for. No? That's all you have to find out as well. Okay, Rona. Guys, just raise your hands if you have given an answer. It's better that way. Naman, find both A and B, okay? Then organic compound A with molecular formula. All right. I guess only one hand is raised. It's fine, guys. If you have given any answer, just raise your hand. It's fine. Come on, guys, make it quick. All right, Ishani. Mhm. Okay. It's time I solve the question then for you guys. So I can see all those who have given the answer, guys. All of you have got it right. Yeah, Jalina, yes, Kavya, all of you are correct over here. Exactly, Vaishnavi. Great work, guys. Great work. Okay. Now, let me show you what's the how to solve this question as well. So, as you can see, understand by now, for ABCD kind questions, guys, you have to be very thorough with one, the tests, and two, the name reactions. Correct? And I guess you have noticed that I'm going to send you a list of all the tests and all the name reactions that you have to do for. Okay, I have already made that list, and I am pretty confident that, guys, if you just go through those 25, total number is 25, the tests and the name reactions. If I combine together, there's total number of 25 things. If you just go through it, guys, there is no questions in organic chemistry that you won't be able to solve. All right, I'm that much confident with it. So make sure, guys, you at least go through all of those things. At least, if you didn't have time, if you're not the one who used to like organic chemistry and not really strong with organic chemistry, make sure that you go through those lists, those name reactions that I'll be posting tonight in the groups. Understood? Yes, Kavya, it's not a big deal. Let's sit one-on-one. I guess that would be better rather than this batch sessions, right? And then we can discuss about this. So just figure out some time in the next 2 to 3 days, and let's just sit on a one-on-one basis. All right. Acha. For the time being, okay, dear, you go for the same thing, Lena. All right. Now, guys, have a look in this question. C2Cl3O2 is the molecular formula given to you, right? Now, it is obtained by red phosphorus chlorine. The last reaction of aldehyde ketones carboxylic acid goes by the name of, what's the name? HBZ. Very well done. Very well done. It's called Hell-Volhard-Zelensky. Very good, Lena. So, right, Tanishka. Well done. Right, Nandita. So, it's Hell-Volhard-Zelensky. What does that tell you? It tells you that CH3COOH, if you have this particular molecule, if you give red phosphorus Cl2, guys, sometimes they can give you as red phosphorus Cl2, sometimes they can give like red PCl3, red phosphorus PCl3 compound. They can also give you like that, or PCl3 compound with red phosphorus. Okay, they can also put the question in this way. Now, if you give that, then what will happen? Red phosphorus in chlorine gas. If you give that, then what happens is you get an alpha halogenation, right? So they're saying you get this molecule by reacting with red phosphorus and chlorine. So guys, if you make this reaction 2 more times, then all the alpha hydrogen would be substituted by the chlorines, and we getting this product. So your molecule over here is nothing but 3 chlorines present in it. Now you check the molecular formula, it would fall right. C2Cl3O2. Now say red phosphorus Cl2 HBZ reaction is only applicable for carboxylic acids. So that's why I took straight away a carboxylic acid here. Understood? So how do I know that it's a carboxylic acid? Because Hell-Volhard-Zelensky is only applicable for carboxylic acids. So I knew that it is a carboxylic acid. So all I had to do is one more carbon, because there were 2 carbons and 3 oxygens. There are 2 oxygens. Now this is another thing, guys. B can be obtained by the reaction of methyl magnesium chloride with dry ice, followed by acid hydrolysis. Yes, we can get, this is your B molecule, guys, and this is your A molecule. You can get carboxylic acid by just reacting methyl magnesium chloride. What is it? It's the Grignard reaction, right? If it was Br, then it would have been Grignard molecule. Okay, there's one thing, guys. If they say this molecule is reacted with Grignard's reagent, Grignard's reagent is specifically CH3MgBr, right? All the other variations of them can be called as organometallic compounds, but not all of them are Grignard's reagent, guys. If they specifically mention Grignard's reagent, always remember this CH3MgBr only. All right. Now, here CH3MgCl with dry ice. What is dry ice? Carbon dioxide is dry ice. Now, guys, tell me what would happen in Grignard. So you can see that it's a metal non-metal bond. Magnesium and methyl is a metal non-metal bond. That means, guys, what would happen? There is a ionic compound, so it would break as ions. Now you always know the metals are the one who gets the cation and the non-metals are the one who gets anion. Now this minus charge, this CH3 minus is a very good nucleophile, so it would be attacking on the electrophilic carbon center. Why would it attack on the carbon? Because carbon is delta positive, oxygen is delta negative. After the attack, the weakest bond breaks. So what would you get then, guys? CH3, C, double bonded O, bond O minus. Now on hydrolysis, on acidic hydrolysis, they have written that dry ice followed by acid hydrolysis. What do I mean by acid hydrolysis? That means just giving a little bit of H plus to make it this kind. Simple. Right, guys? Acha, the previous question, guys, that was the last step of the previous question. I have changed it. You can see that dihydroxylamine and gives positive iodoform and tolerance test. This is the part we have missed. It gives iodoform test as well as tolerance test. See, iodoform test means there is a keto methyl group present. That's what iodoform test stands for. this group is what iodoform test stands for, right? Either this group or this group. An alcohol who is capable of forming ketomethyl. So these two groups gives positive result in haloform reaction, right? If there is anybody who's thinking like, sir, I don't remember all these things and I'm very afraid of this kind of question, organic chemistry is something that I'm afraid of and all, guys, don't worry about it. Just take a few DRS sessions, 1 or 2 DRS sessions with any faculties in here. The things are not at all difficult. Okay, this is something that because the chapters are very big, because the topics are very hard, very huge, that's why you are might be a little bit afraid. Give yourself a chance, okay, before giving up on it. All right. So here this part is there. Now, as it is undergoing tolerance reaction, that means there is an aldehyde, correct? So your molecule is supposed to be capable of both showing iodoform as well as tolerance test. So which one is capable of? This guy can show tolerance test, but not iodoform reaction because you do not have ketomethyl group in here, correct? So this is not my problem. What about this one? This one has ketomethyl group from both the sides, so it is capable of showing haloform, but not tolerance reaction. Exactly, Nandita. But the third one here, it can give haloform from the left side, and it can attack. It can give your tolerance reaction from the right hand side. So this is gonna be the. All right. So let's keep it up to this for today, guys. I have a few more questions as you can see over here. 1, 2, 3, 4, 5, and 6. And there are few more in the PDF that I'm gonna send you guys. I'd be solving all these questions right now, and then I'd be sharing this with you. I've tried my best to solve this question in such a way that so that it becomes self explanatory, so that you can understand it, right? So let's keep it up to this for today, guys. For tomorrow also we are gonna have two webinars, and you have my number. You know I'm in the group as well. I'll be available for you 24 hours, 24 hours for the next 2 days. Okay, till your exam starts. So whenever you feel like you have any doubts or anything, guys, just directly text me with your doubts, and I'll be always available for you for the next 2 days till your exams. I guess 3 days or something. All right. So I guess we can call it a night today, guys. So let's keep it up to this then. Bye, everyone. Thank you. Welcome, beta. See you tomorrow, guys. See you tomorrow.
Thank you, sir.
Welcome, beta. Bye. Yes, Hitesh, you can stay back.
Thank you so much.
Welcome, beta. Bye. Just one second, guys.